Well, it's been about 2.5 months since I made an update about this, so I better film at least something of the part way along. Otherwise, if I don't film anything, we'll just have the finished product, and that'll be a little bit boring, I think, for some people. So I'll just show you what I've got at this point. I'm making a mock-up out of MDF, which is very, very nice to work with, easy to cut. I bought a jigsaw to add to my tool collection, and a compound miter saw as well. And it's made things very easy to get quickly constructed, and it's cheap. I was just about to throw this in the fireplace the other day, but I thought I might just show you how nicely this turns out. So this thing here, I made sure that this would be just small enough to fit on my the CNC machine that I have already, the little mini desktop one. So I've been using that to make those. And I will also have to use it to make the aluminium ones, because I did not get the laser cutter guy to do all of these holes here. He's just going to do these larger plates, which is like the 12mm ones and 10mm ones there. So it's looking pretty good. Everything fit together quite nicely, and it's surprisingly strong and sturdy. It's just rolling on there. And I was kind of thinking it might be nice if I could actually use this to do some machining. MDF is not ideal for that because it tends to take on a little bit of moisture over time and swells and changes shape and everything and gets softer. But for a short while it might actually be good enough to use, is what I was thinking. And as I got further into putting it together, I actually gained more and more confidence in that idea, and about halfway through I decided I'm definitely going to try and machine something with this. In particular, what I'd really like to do is when I get the actual aluminium plate for this main gantry plate, like the big one that goes all the way across, I'd really like to be able to do away with this 6mm spacer block that I've got on there. The reason I've got that in there is because the nut block, let's see if we can take a look at that. The clearance between the back of the nut block and the gantry is pretty tight, and also it's kind of limited by the distance between the base of this and where the ball screw center goes. But if I could recess this block in 6mm that way, it'd be halfway through the plate, so it's still be alright. And then if I could cut a nice long groove all the way down to let that nut block sit back, then we could just get rid of these 6mm plates completely, and the distance between the gantry plate and the front of the Z plate, which is over here. These rails are a bit overkill, aren't they? But they did help to get everything in the right position this way. Anyway, the distance between the gantry plate and the front of the Z plate would be, I think, 95mm or 90mm maybe, which is not really much bigger than my mini CNC, so I'm quite pleased if I could actually get it to do that. Obviously Z motor goes on here. I want to do a little bit more machining on this too. So this is another thing I want to machine, using the MDF machine to machine the aluminium plate. Underneath here I want to take out a bit so that when the motor goes on it's actually sitting a little bit higher up so that the shaft of the motor comes through more. And these rail blocks here, like I said, they sent me the wrong ones. Or no, I ordered the wrong ones, sorry. So the wide spaced ones down there, I didn't want to use those. So I guess I'm going to have to try and sell those now, but it's a bit tricky to sell them without selling the rails as well. And they gave me a different colour the second time when I ordered the new set, which is kind of a bummer, but it doesn't really matter, does it? So let's have a look at this motor. Everything just fitted in really nicely with the way that I had it planned in the CAD. I had to change the CAD a little bit once I actually came to put it together, but there was no major showstoppers or anything. So that motor sits in there, and this motor that hangs down below here comes up to right about to here somewhere. It doesn't quite need to go past this bracket, which is quite nice. It could, because it's... No, it can't. But it doesn't need to, so that's fine. Yeah, anyway, everything's fitting in quite nicely. The ball screws on the bottom seem to work out alright. So the way this works... Oh, yeah, this bit here, I was really worried that this might not work out. But, wouldn't you know it, turned out really nice. And when I'm pulling this along here, everything feels It's not super tight, it's just sort of sitting with gravity, basically the weight of the motor pulling down there. So I could get it a little bit tighter, but I don't think it really needs to be much tighter. And we've got a lot of traction on the belt here, more than half of the diameter. I don't think it's going to hit here, but if that was a problem I could probably put a little bit of plastic in there to separate them, because the top one, it does have a little bit of bounce to it. I haven't actually managed to power these motors up yet. I've just been turning it by hand, but it seems like it'll be okay. Yeah, so this whole plate assembly, these are going to have to be counterbored into here, I think. It would have been nicer if I was able to put this whole section at the back, like in the back over there, but that's where I'm planning to have the liquid draining out, and I don't really want the liquid to be draining out where the motor is, so it's going to have to be at the front, unfortunately. But being at the front, we'll be able to keep an eye on it, which might also be a good thing as well. But anyway, the main thing is that when I grab hold of this and I turn it a little bit, and if I look at this while I'm turning it with my hand there, it feels like I'm just turning this one, like I can't discern any difference in the movement as I'm controlling it. So I'm thinking this is going to work out really quite nicely. And that's what it looks like from the back where the motor is. Takes up quite a bit of space under here, unfortunately. So things were going quite well, pretty good pace actually, until about a month ago when everything suddenly ground to a halt because we had one of those stupid lockdowns again. And the next step was supposed to be, I was going to buy some square steel tubing to make a table for it, because it's just sitting here on these plastic boxes and they are holding up so far, but it's really not ideal and it's getting quite heavy. So I wanted to move it out to the garage onto a proper strong table. I bought some square steel tube on Trade Me, but I can't go and pick it up. So that's kind of annoying. It's probably not necessary to weld up a table, but I have that MIG welder that I bought years ago and I haven't really used it that much. So I want to actually use it and try and make something with steel, which will be stronger and more durable in the long term. Not so good for vibration probably, but hopefully won't have that much vibration, as I'll mention about these in a minute. Plus I'm also between the aluminium deck here and the steel table. I'm actually going to put a whole bunch of MDF or something wooden softer, which will take up a little bit of vibration anyway. But I can't go and get the MDF either. I've finalized my CAD files for the laser cutting, and I sent that away to the laser cutting guy and he gave me a quote, but he can't go to work to make it and I can't go and pick it up if he's made it anyway. So everything's just ground to a halt. Thank goodness the postman's still working, because I have received, just got these today actually, I have been receiving things in the post from China. China's still working, that's great. So this is my 60 volt power supply. This is the drive that I had already. And these two, I got the same kind of driver. Now these are a bit expensive, like 100, I think it's 100 New Zealand dollars each, so it's like 60, somewhere between 60 and 70 US dollars, which is probably a little bit more than I needed, but I did kind of want to make them all match up with the one that I already had. And the other thing is that these motors, these drivers here, they have an option here which is specifically tuned for these motors that I have. So the 86 HS 3545 and 85 there. Those are all perfectly tuned, or they should be perfectly tuned for the 3 motors that I have. And I do a little bit of testing with this one just on its own, running with Linux CNC. So in the meantime, before I've been able to finish any of this stuff, I'm just trying to get used to Linux CNC. And I was quite impressed at how quiet the motor was running. It wasn't pushing any load, it was just spinning this little, that's the load there, little piece of electrical tape just to help me see how it was spinning. But it was so quiet that I couldn't hear it above the noise of this, which has a fan in it and it's kind of noisy. So far I'm thinking, yeah, I'm fairly happy to have spent a bit of money in the drivers department and have something that's like quite nice. Oh yeah, and this is the spindle, very heavy, it's like 3.7 kilos. I was quite surprised, so it seems like it's that doesn't really mean it's powerful, but it should have a decent amount of heat sinking capability at least. This is the VFD, which I'm not a big fan of, to be honest. I spent ages trying to get the RS485 connection working to control spindle speed and also get feedback of the voltage and current and the current RPM that it's running at, and eventually gave up, and I think I'm going to use the PWM control from the Mark III breakout board, which I'll show you in a second. So that was a bit disappointing. Cost me about 2.5 days I wasted on that, because it always seemed like it was just one more thing that needs to be fixed and then it will work. You know, it's like one of those things, and it was very hard to give up once you've sunk so much time into it. It's sunken cost fallacy, you know. Check this out, a FunJet clone. Oh, sorry, back on topic. So this is the Mark III breakout board that I was just mentioning. Nice and cheap, these. I know there are more efficient ways, or faster, more configurable and flexible, or whatever, powerful, that's the word I'm looking for. Better ways to do this these days, but I'm spending so much money in other places that I wanted to just go cheap in this area for now, and I know this will work, that's the thing. So I'll get it working, and this will be something that maybe I'll look at upgrading in the future to one of those FPGA cards or whatever. But for now, I just want to do it the old-fashioned way, which is by using a parallel port. And this computer here, which used to be my main desktop computer back in the day, has been sitting around for about 5 years now, ever since I built that first little mini CNC, which was 2016, yeah, that's 5 years ago. I've decided that I'm going to set this aside to eventually use for Linux CNC one day. It's a Core 2 Duo, reasonable spec, like 3 gig, whatever. You don't need that much of a powerful computer to run Linux CNC, but the important thing is that, in my case at least, the important thing is that it has that parallel port there so that I can use this. Oh, another very important thing about these parallel ports, or the cables, don't get a null modem like serial cable like I did. You need one that actually has all of the 25, well, you don't necessarily need all 25 cables, but you want one that has all the cables going in parallel for all the pins. And you'll know those because they have a nice thick fat cable like this. So the first one I got was just a null modem serial cable, and when it arrived in the mail I was like, wow, this cable's really thin. It's amazing how they could fit 25 wires through there, but of course it wasn't 25 wires, it's only about half of them. Yeah, so I didn't get very far with that. Oh, yeah, speaking of wasting time on things, I spent about a day fiddling around with BIOS settings and trying various kernel options and stuff with Linux CNC to try and improve the latency, which is important for reducing the lag, I guess, in the time that these pins get switched off and on, because the computer is directly controlling every single step pulse for all of the steppers. So it's very important that they come at the right time, because if they come a little bit late, what you're telling the motor is that it needs to stop. So if the motor's in the middle of a movement, at least if I understand it correctly, this is why it's so important. If the motor is moving something at this speed, say, and it's very heavy, and then the step pulses get delayed, it's going to try and stop. So yeah, it's got that momentum and it probably can't stop it, so you're going to miss steps. I think that's why it's important that the latency is as fast as possible. But anyway, I think all my twiddling and tweaking was eventually worth it, because I've ended up with something that's very good, actually. Among the better of the settings or the results that I've seen for the latency test. So I'm glad that I did keep this aside for that purpose. As part of my fiddling around with the null modem serial cable, at one point I thought I'd ruined that parallel port because it stopped working. At least I couldn't, when I was using my oscilloscope to probe the pins in the back of the parallel port directly, like just putting my oscilloscope straight in there, it wasn't giving any pulses on the oscilloscope, and I thought I'd broken it. So I managed to find a couple of these on TradeMe, very cheap. These old PCs with the parallel ports, they're, you know, they used to be pretty common, but not so much anymore. So they're not that easy to find, but when you do find them, they're often quite cheap. And I got these for 40 New Zealand dollars each, so that's about 25 or so US dollars. They're not quite as good for the Linux CNC usage as my other one. So these are about 14 nanoseconds. Oh no, what is it? 14,000 nanoseconds latency. Does that make sense? nanoseconds, or yeah, whatever. They're about twice as slow as the other one, but they're still usable. Turns out that my parallel port on the other one was not broken. That's okay, so I'm going to keep using that one. But I'm starting to have little daydreams about maybe making a Linux CNC pick and place machine at some point in the future. So it would be nice to have these to use for that, perhaps. Hey, look at this. You can see where the wire for the welder was sitting on the floor, and there's a whole bunch of tiny iron filings, and because of the magnetic field set up by the wire, it must be fairly high current, all those iron filings have aligned themselves sort of perpendicular to the direction of the wire, because that's where the lines of magnetic flux would be going, like in a circle around the wire. It's pretty cool. I was just about to put this last cross piece in there, but I ran out of MIG wire, which was a little bit annoying, but it did give me a few days to reflect on what I have at this point. Yes, a few days, because normally running out of MIG wire would only set me back by about 1 hour, because I could just drive into town and get some more. But no, we've got to have these stupid lockdowns, and the Mitre 10's website wasn't working properly. You can't go and pick it up, at least from where I am. And Bunnings' website also had some problem where I couldn't select it. I ended up buying it on Trade Me. So anyway, it's like 4 days later. Haven't got anything done, other than I have discovered that there's a nasty... well, actually, what's interesting is when you try and move it like this, it seems okay until you give it a huge shove. And it turns out there's like a 1.5 centimeters off the ground there. So there's quite a big warpage in the top. That's the top, obviously, on the ground at the moment, but that's the top. So that's a little bit annoying, and I measured all around the place to see if I could figure out where it was coming from before I put this last piece in, just in case I could do something with this last piece to try and fix it a bit. And there's also some joins that I haven't really done fully yet. Maybe I could undo 1 or 2 of those. But when I realized that it was that top panel there that has the warp, I just sort of gave up, and I think I'm just going to have to live with it. And the problem's partially because instead of turning these long pieces here the way that I should have, because they each have a little bit of a kink in them, a bit hard to see, but you can see that kink there maybe a little bit more. Instead of taking that into account, I just turn them the way that would be the most cosmetically pleasing, like the smoothest side would be facing forwards into the top. So that wasn't such a great idea maybe. The other problem was perhaps that I welded all along one side and turned it over and then did the other side afterwards, I think. So perhaps that wasn't such a good idea either, because, you know, with the heat, or as they cool down, they can warp a little bit. But anyway, I think I'm just going to stick this piece in, not worry about it too much. And this bit here, or one of these here, is just going to have about 1 centimeter removed. And that's not as bad as it sounds, because I do want one corner of this table to be lower than the rest of it anyway, so that any liquid that I use for coolant or whatever is going to go towards one corner. So I do want it to be like that, but I had sort of planned to do it with a little bit more care and maybe have some sort of a screw adjusting thing in here. But the fact that it's going to be a little bit crooked right from the beginning, not necessarily a bad thing, as long as it's on the leg that I want it to be on, which it will be. Okay, that's everything fully welded now, and it's looking pretty good actually. I did of course realize that I didn't need to take the length all off one leg. I could take it half off the 2 legs that were too high, so I did that. That's 5 millimeters off the bottom of those 2, or the bottom of those 2 actually. And now, oops, it's looking nice and stable. And the important thing is that this section here where the CNC bed is going to sit that is actually pretty nice and parallel and level and everything, just at least looking, you know, putting this on and checking, and also just putting a piece of MDF like I'm going to have on there, and it all seems straight enough. There's a little bit of a oh, where is it? Somewhere here. Yeah, it's a little bit crooked there, but for the most part it's pretty good. And just by chance, Murphy's Law was not watching while I was building this, because actually this is going to be really hard to show you, I think, but there was a 50-50 chance that that top panel part would warp in the way that would be inconvenient for me, but it didn't. So I don't know what Murphy was doing that day, but yeah, it's a bit hard to see really, but the front left corner, as we're looking at it from here, is the one that I want to be the lowest, and that actually is the lowest. If it had have warped the other way, that would have been rather annoying, but as it is, I'm quite happy with that. In this fairly open section here, I actually wanted to have a couple of other pieces going that way. Might not be necessary really, but since I'm in the middle of fabricating stuff and I have some bits there that I can use, I will make those as well. This is just a thing that I got from my mum when she was moving house a while ago. She didn't want it and I was like, okay, I'll take that, having no idea what I was going to use it for, but finally came up with a use. I actually thought this might be quite useful to stick as it is, like up on here as an extension bench. So I will do that later, but not with this piece. I'll have to get some other pieces and like make a custom fit. It's just the width of these bits here is a little too narrow to fit in there, that's all. But it would have been nice if it could slide in there, you know, that would be quite convenient. Okay, that's pretty much all the main structure done now. I put these two bits in here, and I also put another one across there because that's where the computer is going to sit, and the other box with all the electronics in it. I actually have another one of these things that I got from my mum. I guess they're part of like a desk or a bench or something. So I could use that for something as well, but you can see what I mean about it not actually, doesn't actually fit across there very well, because I was thinking it would be nice if I could slide it in here and have an extra piece of bench here. And now that I've had that idea, I do want to make the extra piece of bench on here, but I'll just have to do it with something else. Or maybe I could use that, I don't know. There's another bit there. Perhaps between all of that together maybe something could be done. But I don't want it to be permanent. I want it to be either detachable by sliding out or by just folding down like that would be kind of nice. So the next step, I was thinking maybe I could paint it, but I still have to figure out what I'm going to do with the bottom of the feet there. They're just open end of the tube at the moment, nice and sharp to cut your fingers on. So I'll have to put at least something like a flat plate on the bottom. And I also want to put some wheels on here, some caster wheels. So I think I'll get those together. I don't have those yet, so I'll get a few more bits and pieces to do that, and then maybe paint it later on when I've done that. Okay, it's a few weeks later now. The stupid lockdowns have abated, at least to the point where I can go to a hardware store and actually pick something up off the shelf and inspect it before I buy it, instead of having to get everything over the internet and mail and then find that when it arrives it's not quite right and wait another week or so to get the next piece. Anyway, here we are. So what I've decided to do is I'm just going to weld some of these caster wheels on there, directly onto, around about where they are there. And they are just high enough to clear the top of this, where I'm going to weld that, which is actually a washer. And into the top of that I'm going to weld one of these. And then this one of these is going to screw into that, and when we do that it's going to just clear this by just a little bit, and then I'm planning to also put a little block of wood under this on the floor for this to sit on. So by the time that's all done, the wheels should be a fair bit off the ground by maybe an inch or so, and then to move it around, what I'm going to have to do is put a jack, like a floor jack for a car, under this, lift this up to the point where I can unscrew the unscrew that, and unfortunately I'm actually going to have to take this all the way out so that I can, when I put it down again, there's going to be enough room for the wheels to touch on the ground. So it's going to be a little bit tight, and I'm also not sure about this piece being plastic here. There was no load rating mentioned on these when I bought them, So could be that the heavier end of the bench, which is going to be the far end where most of the weight's going to be, might actually cause this plastic to crack. I don't know, but we will find out. So that's how that turned out. And there's only about 2 centimeters clearance for the wheel above this point here. And the little plastic knobby bit is almost 2 centimeters high, so I actually do have to take it all the way out if I want to be able to roll this table on the ground. And I managed to mess up these plastic bushing. Oh, they're not bushings, they're just, there's some grease on the bearings in there, and I think this plastic bit's just there to stop dirt from getting into the grease in the bearings and stuff. So it's not really that important, so it doesn't matter that I melted it a bit there. So let's turn this upside down and see if it rolls. Because the clearance is so small, it's not going to be able to roll like on a upper slope, or you know, if you're going up a slope and then you go onto a flat. Basically, you can only roll this thing on flat ground. Is how it's going to be, but I don't think you'd want to be rolling it on a slope anyway, given how heavy it's going to be. Okay, that'll do. Well, I don't really want to have to do that every time, but looks like I might have to. Okay, I just put all those bolts into the bottom again and screwed them all the way up so that they're as short as they can be, and then lowered it down. And I think the fact that they're plastic on the bottom might actually be a blessing in disguise, because they're so close, like they're almost exactly the same height as the wheels. So when I pull on it, there's a resistance, but then it will start rolling. It's almost like they're exactly equally the same height, I think. Okay, I'm just moving everything out to the garage now that I have a nice bench to put it on. And I'm just going to start by putting my mock-up plate on top there. And because it has this motor mounted underneath like that, the spaces need to have a bit cut out like that. Everything else is okay though. They have just the right amount of space here on the side for this bit to slide along. And vertically it's all nice as well. And I did it this way because it's quite cheap, and it will deaden some of the vibration, I think, and it also adds quite a bit of mass at the top of the table. So if the gantry is moving quickly, I'm hoping that this will be sort of a ballast to that mass as well. Don't know if that's going to work too well, but it's quite cheap and easy to buy. I can just pick this up in my car in about an hour, at least when we don't have any stupid lockdowns. And if I change my mind about it later, or if I want to make it higher or something, that's easier to do as well. This height here is just so that we can clear that there, or clear this actually, is what it needs to clear. While I'm waiting for some other things to arrive, I thought I might make a start on mounting the electronics gear inside this box. And I thought this metal plate that was in it was going to be kind of thin and floppy, so I made a MDF backing for it to reinforce it a little bit. But had I just taken it out and inspected it first, I would have realized that, as well as being quite heavy, it's quite strong. It's like 1.5 mil thick steel, maybe, oh, it might even be 2 mil thick. It's quite heavy and strong, so I think I'm just going to go with that only and just mount things straight onto that will be good enough. So that's probably good enough as it is, just mounted from the bottom only, but there's about a 1.5mm gap in here, so if I just jam something in there, then it becomes quite solid. So if I just do a few of those, and then when I take it out again, I can just pull them out. Yeah, that'll do. This mounting plate that goes inside the cabinet, since it's decently thick, it's 2mm, or looks like about 2mm, that's thick enough that I can just drill a hole and tap it and then use some screws like this to mount everything. And it's going to be quite convenient, I think. In the next couple of photos we're going to see some 12cm PC case fans which I use to move the air around inside this enclosure. This is my little diagram for figuring out how the wiring was going to go. I managed to actually get it to mostly sit almost completely in a 2D plane, that is to say the wires not really crossing over each other much, just this little bit here. So this we've got the VFD here, power supplies, PC case fans here, stepper drivers here, and then the Mark III breakout board there. So the stepper motor wires are going to go out there, and then going to go into drag cable. Or the X motor actually just goes directly to the X motor, which is very close behind, so that's quite nice. The Y and the Z have to go a little bit further, so they're going through a drag cable. And the spindle cable, which is these sort of pink salmon color ones down here, they kind of have an influence, or they potentially could cause interference with these stepper wires, and also these smaller wires here, which are the limit switches, also going through the drag cable. So I wanted to keep this noisy spindle cable away from the other stuff as much as possible for as long as possible. So it's going to go out the bottom here, in between those little blocks of wood that we saw at the bottom of this case, and it's going to join. I might not even put it through the drag cable at all. We'll see how it goes, but anyway, that's why it's going out the bottom rather than out the side with the other ones. And I'm going to put a baffle in the middle of this case to completely block air from the top to the bottom, and only the fans here are going to be able to, like, air will go through there obviously, and it will go right onto the stepper drivers. So this part here will be the warmest, I'm thinking. The VFD, I don't know how warm it gets. The fan seems to go quite a lot, but I don't think it gets super hot, and the power supply is probably not too much either. I'm thinking probably the stepper driver is going to be the warmest part of it. And anyway, so this is how I'm envisaging that the air will be flowing through there. That's the point of having these fans. So I just made a simple MDF mount for them to go in there, and the top of this here goes almost right up to the lid of the case when you close it. So there's probably about 0.5 centimeter that I'm going to have to baffle with something soft here. Now these are 12-volt motors because they're made to run off a PC power supply, but I'm running them from 24 volts and I'm putting them in series, which should give them, you would think, I was going to say about 12 volts, right? Well, I actually checked, and it's like bang on 12 volts perfectly for each of them. So I'm quite pleased about that, and it means that they're not going to be run at over voltage or anything like that. Well, at least for now. Maybe in future something will go wrong so that they become unbalanced and one of them gets too much voltage, but hopefully that's not going to happen for a long time, if ever.